This lesson is going to be something of a workshop on the graphs of functions. So you'll notice I've already got a lot of stuff prepared here. And if we were face to face, this would be a handout or something like it. I would pass it around, then we would talk a little bit, then I would give you a few minutes to work on the first problem, then we would come back, talk it through, I'd give you a few minutes to work on the second problem. So I'm going to try to simulate that same environment here. As I'm working through this, I will occasionally tell you, pause the video here for a minute and work out the next two problems on your own and see if what your understanding of it was matches what it actually is. I'd like for this to have that sort of workshop feel, even if we're not together. You'll notice that up at the top in red, I put this little recall. Recall, points on the graph of a function of x are pairs in the form input, comma, output. So in this box or this moment here, I said that it's a function of x, which I don't believe I've said before, because I want to emphasize that the way that we are visualizing functions, we've got an x-axis and a y-axis, and we plot inputs along the x-axis. It is not necessary to always plot inputs along the x-axis. Later on in your mathematical lives, you will get to a point when you start looking at functions of y. You will even get to a point where you start looking at different coordinate systems. But for now, we have functions whose graphs are on the rectangular coordinate system with an x-axis and a y-axis. And for now, we are plotting inputs in the x-coordinate and outputs in the y-coordinate. We're going to keep coming back to this over and over and over again as we work through these two examples and future examples having to do with graphs. So first problem, the graph of a function is given below. So you'll notice that I just made a doodle. All right, and I was careful on this doodle to indicate that 1 square is equal to 1 unit. So I was careful to indicate that this is 1 on the x-axis and this is 1 on the y-axis. It is not possible to overstate the importance of a clear scale. So whenever possible, really try to A, specify what your scale is on a graph, and B, stick to that scale. A graph becomes very misleading very quickly if you do not have a clearly communicated scale. So for number 1, part A, I'm going to work through the first two problems, and then I'm going to ask you to pause the video and try the remaining 3 problems on your own to see if you get the gist. So part A says, find the value of f of negative 1. So remember, f of negative 1 is the output associated or corresponding to with the input negative 1. So in this problem, you know the input, and I'm asking you to find the output. Okay, now let's go back to over here where we put this reminder definition. In our graphs, inputs are x-coordinates, outputs are y-coordinates. So if I'm asking you for f of negative 1, I'm telling you the x-coordinate is negative 1, find the y-coordinate. Well, let's see. I'll actually still use my pointer. Here is negative 1 on the x-axis. Now, I'm supposed to find the y-coordinate. So I'm going to dot up until I meet the point on the graph. And there is that point on the graph. I'm asking you to tell me what is its y-coordinate. Its y-coordinate appears to be 1. So f of negative 1 is 1. Exactly the same thing for f of 0. So in this case, the x-coordinate is 0, and I'm asking you to tell me what is the y-coordinate of the point whose x-coordinate is 0. So same thing, x-coordinate 0, we're here. Oh, wait a minute, as soon as I touch the graph, I touch the point on the graph, right? This graph passes through the origin. The question came up in Office Hours yesterday. Is it common for a graph to pass through the origin? And the answer is no, not particularly, sometimes. But you will notice that some graphs do pass through the origin. So this point is the point on this graph whose x-coordinate is 0. And its y-coordinate happens to be 0 also. So f of 0 is 0. Now here, I'm going to ask you to pause the video. I like setting a timer on my phone, but you don't have to. Try seeing if you can pause the video for 3 minutes. So give yourself either exactly 3 minutes if you want to use a timer, or approximately 3 minutes, and work out these 3 remaining problems. Then restart the video and we'll keep talking. Okay, welcome back from trying these problems, and let's see how you did. So f of 2, same thing, right? F of 2 is the output that's associated with the input 2. So I'm telling you what the input is, and I want you to find the output. Just like I did with f of negative 1 and f of 0, I'm going to find 2 on my inputs axis, on my x-axis, and then I'm going to go up to the point on the graph. All right. So there's the point on the graph, and now I'm going to dot over to the y-axis. It looks like the y-coordinate is 3. So f of 2 is 3. All right, let's look at f of 4. So f of 4, 1, 2, 3, 4. There is the point x equals 4. That's 4 on the x-axis. And once again, the point on the x-axis is the point on the graph. So what is the y-coordinate of a point on the x-axis? Well, that's 0. So that means that f of 4 is once again 0. Last but not least, f of 6. Okay, so here is 4, 5, 6. So there is 6 on the x-axis. That's my input. Now I'm dotting up to the graph. There it is. And I'm going to dot over to the y-axis, and you see that once again this y-coordinate is 3. Okay? Now, in all of these examples, I've been saying dot up to the graph. That only has to do with the fact that this graph is entirely on or above the x-axis. The graph is never below the x-axis, so I never have to go down. If this graph fluctuated, sometimes above, sometimes below the x-axis, I would go to where the graph is. So if I had to dot down, I would dot down, and then the output is negative. If I had to go up, then I go up, and the output is positive. For part B, find all the values of x for which f of x is equal to 1. So here, I'm telling you the output. The output is given here. And the question is, okay, well, what inputs correspond to that output? So notice that there's the possibility that the answer here is more than one value, because again, with functions, no input can correspond to more than one output, but you can have the same output that more than one input matches to. So that's totally fine, right? So there can absolutely be more than one answer to question B, even though there will not be more than one answer for any of the parts of question A. All right, let's see what we have. So the output here is given, which means we know the y-coordinate. So we want the output to be 1. So there it is. And what I'm going to do is I'm going to look side to side at the points on this graph, and I'm going to see, hey, there are 4 points on this graph whose y-coordinate is 1. Well, what are they? Well, this one, the x-coordinate appears to be about -1. This one, oh, look at that. The x-coordinate isn't quite 1. It's a little bit smaller than 1. So I guess we'll approximate it. We'll say, well, it's maybe about 0.8 or 0.9. That happens sometimes. Not terribly often for our purposes, but it does happen sometimes that the point isn't nice and you have to sort of ballpark. Then there's this point here. Okay, so that point's x-coordinate appears to be 3. And then there's this point here. This point's x-coordinate appears to be 5. So there are 4 values of x for which the output that this function assigns to them is 1. -1, approximately 0.8, 3, and 5. Yeah. So the values of x for which f of x is 1 are -1. I'm going to say 0.8, 3, and 5. So again, that 0.8 is an approximation, and it shows us why graphs are inherently flawed. You can't quite tell exactly what happens there. You can't quite tell the exact value of x, but you can see that it's a number very close to 1 and a little bit less than 1. Okay, so that was problem 1. Problem 2, we're going to do very much the same sort of thing, just with a different graph. And what I'm going to do is I'm going to encourage you to actually take some time for both parts A and parts B to see if you can work this out on your own, and then come back and we will revisit. So real quick, just to get you started, we have this graph of a function. Here it is. And for part A, I'm asking you to find the value of f of -1, f of 0, f of 1, and f of 4. So take a few minutes, maybe put 4 minutes on a timer, pause the video, try these, see if you can sort of follow the same reasoning that we did for part A of the first problem to answer the questions here. And then once you've given it a shot, once you think that you've got it, come back and we will talk about these. Okay, welcome back. So let us talk about the parts of the problem A. Again, I want to point out for all of these, you know the input. You are given the input in this problem. So the question is, what is the output that the function assigns to this input? So f of -1, all right, well that lives here. So remember how I said in the previous example, you might have to scan up or scan down? You're looking for the point on the graph with that x-coordinate. Well, what happens as you scan up and scan down here? Oh, well, there is no point on the graph with that x-coordinate. So what that tells us is, because there is no point on the graph with that x-coordinate, -1 is not in the domain of the function. So you could say f of -1 is undefined. You could say it doesn't exist. But this is exactly what it looks like when a value is not in the domain of the function. There is simply no point with that x-coordinate. So f of 0, right? So here is 0 on the x-coordinate, and then you scan up and down, and you notice exactly the same thing. Now, what's a little bit different is it looks like the graph of the function is approaching having an x-coordinate 0. The points on the graph seem to get closer and closer and closer to 0, but they never quite get there. This is actually called asymptotic behavior, and it's going to be a big deal for us later on. This is just a quick glimpse of it so that you kind of see what it looks like. But once again, we see that 0 is also not in the domain. So once again, f of 0 is not defined. So I'm thinking ahead to our next lesson, in which we're going to talk about how you find domain and range if you're given the graph of a function. And this is the sort of thinking that we do. So kind of allow that to kind of percolate in your brain a little bit. F of 1. Okay, well, f of 1, so here's 1 on the x-axis. Oh, well, that's where the graph crosses the x-axis. What is the y-coordinate of the point that's on the x-axis? It is 0. So f of 1 is 0. Notice that 0 may not be in the domain, meaning there is no point with 0 as its x-coordinate, but there's absolutely a point whose y-coordinate is 0, so 0 is absolutely a part of the range. Okay, last but not least, f of 4. Well, here is 4. 1, 2, 3, 4. Here is 4 on the x-axis. The graph is above the x-axis here, so we dot up. The y-coordinate of this point is there, and so f of 4 is 2. Okay, good. For the next question, we're asking, find all the values of x for which f of x is 3. So just like we did for part B of the first example, this is a situation in which you know the output. So the output is given. And I'm asking you to find the input. Speaking in terms of x-coordinates, y-coordinates, I've told you what the y-coordinate of the point is, and I'm asking you to tell me what's the x-coordinate of the point, or the points, if there's more than one of them, whose y-coordinate is 3. So we're going to find 3 on the y-axis, and then we're going to scan, and it looks like there's only one such point, and here it is. There is the point whose y-coordinate is 3, and the x-coordinate is actually 8. So you can count the squares from the origin to here, and you will see that there are 8 units. So there's only one value of x for which f of x is 3. So there's not always going to be more than one, and that is 8. So this concludes a little workshop surrounding the graphs of functions. In our next and final video for the week, we're actually going to look at graphing some functions, specifically going back to piecewise defined functions, which we talked about in one of our earlier lessons. See you soon. Bye.